Dr. Richmond Asamoah is a research fellow from the Future Industries Institute at the University of South Australia and a chief investigator in the PRIF Mining Consortium. Richmond has over 12 years of in-depth knowledge and hands-on experience in mineral processing and extractive metallurgy in tandem and surface, interfacial and data science. Richmond's research interests are in physical separation and beneficiation of complex minerals, specifically low grades and wastes, hydrometallurgy, including bio, and machine learning and data analytics, having links with environmental sustainability. Richmond also leads and conducts research as part of the Australia-India Strategic Research Fund, funded by the Australian Government's Department of Industry, Science and Resources. Richmond is investigating advanced recovery of battery materials and rare earth elements from ores and wastes. Richmond's also looking forward to his trip to India and Japan in November, where he will have an opportunity to talk about the PRIF projects. Welcome, Dr. Richmond Asamoah.
Thank you very much, Ruth. Yeah, I'll be sharing a lot of what we're discussing today in that trip, so that should be exciting. So today I'll be talking about what we've been doing, and Bill highlighted Bismarck's work, which forms part of what we've been doing with Magotteaux, for developing predictive models to enhance and improve flotation performance. So this falls in the flotation section, and particularly making the model more robust to be able to withstand changing conditions in the operation, which is one of the critical issues. Okay. If you, like me, that I break time had to go and pour in a lot of coffee, you will know that you will not like me to bore you too much with details. But more importantly, what I would like to say at the end of my talk is three things: that machine learning models can make good copper recovery prediction, and also the features that are selected are very important. But again, having pulp chemistry in there helps to define the features that are being used in the predictive model and improve the flotation model performance. So that's key stuff. This is very important, with the key message being highlighted in the course of the day as well, with decreasing ore grades. So this is a major challenge in the future. So even today, if we're dealing with 1% copper or 2% copper grade as feed, prediction is showing that we could have grades 0.2% in the future, and that means we need 10 times if we want to produce the same amount of copper today. But again, you look at the curve on the flip side there, that prediction's showing that we need far more than what we are producing today in the future. So we need to develop new technologies and have smart ways of extracting copper for the future. I'll move quickly because of our time. So that's one very important benefit of what we're trying to do and what we've been doing with the Magotteaux. But also, as Chris highlighted in his talk, flotation process has so many variables that affect the performance. And some key variables around the pulp electrochemistry are not being monitored because of changing ore characteristics, and that affects the chemistry for flotation. So in that chart, you can see that some of the minerals, which are also very common in BHP ore, charcoal pyrite, chalcocite, have a sweet spot for pH or redox potential for them to be effectively recovered. So not being able to monitor that and control that affects the flotation performance. And also, this then allows us to have more stable operation because we are able to add the right amount of reagents, and that means that we can maintain our output or characteristics. And so downstream processes don't suffer issues in performance. And also we have higher throughput with some of the studies we've shown, 17% copper production when we are able to implement these models. But again, with interest on environmental impact and benefits, this means that we're saving amounts of energy that is being used, and also water savings in the process. So what we actually did So Bismarck, whose work forms part of this, finished currently with Talison Lithium. We spent quite some amount of time on site, BHP, collecting data with pulp chemistry and also without. And with the help of Chris, got pulp chemistry sensor on site. We were able to get large amounts of data from 2015 and pre-processed that data set, did feature selections, and developed predictive models and tested that. For the flotation, existing monitored variables on site, about 25 of them in the flotation circuit, we initially investigated different feature selection techniques. We identified that the regularized neighborhood component, which is the one down, gave us the best option because it's able to select some key variables which, under normal circumstances, the metallurgist, if you look at the first technique, you see the red one, things like throughput and also particle size were not picked up with the Pearson approach. But in Chris' talk, you could see that particle size is one of the key things and throughput that metallurgists always look out for. So we've got this model that is able to pick up those and also improves the performance of the model. So this is using just the plant data set to develop the predictive model. Now, what happens is because if you don't have some of the key variables that are also changing in the process, so for instance, the dissolved oxygen or pH or redox potential variables which are relevant for changing all characteristics being fed into the process plant, if they are not part of the model features that are being used, you have this kind of situation where the model works very well with the 2015 to 2018 data set, but when a known data set is introduced where these variations happen, you begin to have those failure robustness of the model. So with a new data set that we were able to collect from site, we've been able to show that the pulp chemistry variable actually affects even the selected features at the start. So we had 9 features which were established as good. But when we introduced the pulp chemistry variables like pH, EH, dissolved oxygen, oxygen demand, some of the earlier selected features actually dropped out, and we were able to reselect those input variables and again had an improved model performance in that case. So moving on from here, what we're looking at doing is to collect more data set and at the end of the PRIF have the model more validated and test and demonstrate how the changing conditions are captured and have a more robust model. We are also looking at restoring the Magotteaux on site, which we had a chat. So hopefully that's going to happen soon. And so we can collect a lot of data set for this testing. And the other thing that is ongoing is software development, which we have in 2 researchers employed as part of the PRIF extension. That is ongoing testing, Bill mentioned, and also Van will be working on this. And we're looking at having the data set, which gives us a current state of the plant. But when it goes through the model, it can provide recommendations to the plant operator. And the plant operator then implements that on the site, making sure that we are adding the right amount of reagents or making sure we're maximizing our copper recovery, particularly for the operation. So this is where we currently sit, TRL 7, which is equivalent to commercial readiness of about 3. We forecasting that at the end of the extension, we'll have a technology readiness level of 9, which is also around CRL of 5. Pretty much the technology is already in market. But this work is also demonstrating how having critical sensors, like Chris mentioned, the solution chemistry measurements on, and these are affecting the flotation process, and so how those sensors on the side can help improve the model's performance. And so you'll be hearing after this some of the things that Amalie is doing as part of the training center on particle size, particularly on the hydrophobic particle size distribution, which affects that, and those things can also feed onto the Magotteaux sensor. So that will be all for me. I'd like to thank and acknowledge our UniSA team, Bill, awesome mentorship for the past 5 years on this project. I think Bill has changed my life. So I really want to appreciate him for the leadership he has given throughout. Chris, his time throughout the project, we went to site, drove around, have always committed to provide the support. Kavita, Plan Data Set, Kati, it was awesome working with the team. So I would like to thank them all, and also all the PhD students as part of the project. And all our industry partners, thank you very much for listening.
Do you have any questions for Richmond? Everett's
just to pick up on the issues that Simon raised in his talk, it looks as though you now have a software package. What's your plan to take that software package into industry? What's your transition rate from here?
Yeah, so that's a very beautiful thing, similar model like Simon highlighted. So with the Magotteaux, you can see that it's already a product in market through Magotteaux. So what then we do can be easily implemented on site, and Chris has been very supportive and upfront on that most of the research work that we are already doing, they can reassess that and implement it on site. So the equipment for measuring all these are already available and continuously being developed by Magotteaux. And again, we are not working alone. So that's a very important part, that most of the things that we do in Magotteaux is also in-house working to improve that as well. So it then enhances implementation of our results and outcomes, and particularly making it relevant to the industry.
Thank you, Richmond.
Yeah.
Our next speaker is Amalie Moeller, a PhD student in the ARC Training Centre out of the University of South Australia. Amalie joined the Training Centre in 2021 as an international PhD student after completing a Master's in Pharmaceutical Sciences. During her PhD, Amalie is looking at fundamental physical chemistry in mineral processing to develop a sensor that can separate hydrophobic and hydrophilic particle and size each stream. Amalie is also associated with the Centre of Excellence in Minerals, where she is working with and helping other researchers to progress their projects. In 2023, Amalie was awarded Best Oral Presentation at the Australia and New Zealand Nano and Microfluidics Conference and published an encyclopedia chapter. When Amalie is not in the lab, you can find her baking sourdough breads or simply enjoying a good cup of coffee. Welcome, Amalie Moeller.
Thank you, Ruth, and thank you for having me today. Big green button. So yeah, my project is a part of the ARC Training Centre. I'm located out in Mawson Lakes at UniSA. Let's see if we can get this to work. So in the training centre, my project is located over in the flotation circuit. HDR 13, if anybody is familiar. And my project is about looking in or developing a sensor that can separate hydrophobic and hydrophilic particles from this flotation area, so a flotation slurry. And then further off afterwards, sizing these particles as well, so we can have the particle size distribution of the hydrophobic particles alone. But let's start with a little bit of background that most of you would potentially know. So in flotation, we are looking at or have a critical contact angle that describe, or a particle needs to exceed for that particle to be able to float and be recovered in flotation. As you can see on the graph there, larger particles have a higher critical contact angle than smaller particles. What my project is looking into is particle phase transfer, where we have a similar phenomenon. In particle phase transfer, we I add, or we use, instead of an or a gas phase, an oil phase instead. So we have a similar phenomenon with a critical contact angle for this phase transfer to happen, and also have a similar size dependency, but we have a little bit of a larger size range that we can work in to get transferred in particle phase transfer. And another advantage of this as well is by having an oil phase, we can change the interfacial tension of our oil, and thereby tune what particles we are recovering into the oil phase, which will give us the full recoverability of a flotation sample. So we can ensure that we have all of the valuable phase that we need and use that for sizing afterwards. So what is particle phase transfer actually? It looks something similar to this in an ideal world. So in the bottom on the left, you have an aqueous phase that could be the flotation slurry, and then we add a non-aqueous phase, oil phase on top of that. By mixing these two phases together, we have particle oil droplet collision, similar to particle air bubble collisions in flotation. And the theory here is that if the particle exceeds the critical contact angle, the oil droplet will spread over the particle, and that particle would transfer into the oil phase. And after we've mixed enough, initially by giving it a good shake in the lab, pretending that we are mixing a drink, and then we can let them separate out, and the hope is that we can get hydrophobic particles transferred into the non-aqueous phase with all of the hydrophilic particles staying in the aqueous phase. So as you all know, and if you didn't, people previous to me have talked about it, flotation separates hydrophobic and hydrophilic particles in a size range, specific size range. My project is not trying to compete with flotation. Instead, we're trying to use this particle phase transfer to get the full recoverability of a flotation sample, so we can use all of these particles that we've separated and get the particle size distribution of the hydrophobic particles alone, so we can see if what we are trying to recover is actually recoverable in flotation. So as more as a diagnostic tool or a way to optimize flotation itself, because there's no way adding any oil phase to flotation will be cost effective compared to flotation, but a way to try and get as much information out of the slurry that we can to optimize flotation itself. And all of this, as previous speakers has talked about as well, is we're aiming to get implemented into the Magotteaux with Magotteaux and Chris Creed, but we're still in the early stages as well. So what I've been doing, or what I'm looking at in the first part of my PhD, is 3-phase systems. So I have an aqueous phase, pure water in my case, and then a non-aqueous phase, which for me is different oil phases. And I want oil phases of different interfacial tension. So I do this by having a low interfacial tension oil, MCT, medium chain triglycerides, that I mix with a high interfacial tension oil, in this case dodecane. And by mixing it in different ratios, we get oil phases of different interfacial tension, which is great and what we want. So to characterize these oil phases, I'm doing something similar to what Piotr explained earlier, measuring the interfacial tension with something similar to this. Won't go into too many details here, but what we get is graphs looking like this, which is really nice. So in blue at the bottom, hiding behind the green, we have the low interfacial tension oil over time, and in purple at the top, we have our high interfacial tension oil over time as well. And we can see that we have a nice stable interfacial tension, nothing absorbing to the interface, which is what we want. So I'm happy, my supervisor is happy, we move forward. And moving forward was into these oil mixtures, which are the ones you can see in green, red, and orange. And when we start mixing oil phases, we were a little bit concerned that we might see some demixing of the oil phases. Luckily enough, again, over time, interfacial tension is stable, meaning by mixing these two oil phases, we create new oil phases with a different interfacial tension. Again, happy, we can move forward. So the next step is to introduce the third phase in my systems. And I've been looking, which is a solid substrate. all of my work is on model systems, so I've been using gold that we modify with different tiles. Similar concept to with the oil phases. I have two tiles. One is CH3 terminated, so hydrophobic, and one that's OH terminated, so hydrophilic. And by mixing these in different ratios, we get substrates of different hydrophobicity, which is what you can see in the graph with a little nice little AFM image and a sessile drop insert as well, just to show you that we can actually, by doing this, we get model substrates with different hydrophobicities that we can use further on. So to analyze these free-phase systems, I've, again, something similar to Piotr, done droplet collisions. So releasing a single droplet of a specific size into a column, and then letting that droplet rise to the top and collide onto a substrate, one of our different modified substrates, and recording this approach, collision, and spread of the droplet over the substrate with a high-speed camera, which gives us something looking like this. Let's see if the video works. Oh, yes, there we are. So by analyzing all of these single frames individually, we can get, after we have the rupture, thin film rupture between the droplet and our substrate, we can measure or get the contact angle during this spreading, which is what you have here. So on the left, you can see individual frames from these collisions. On the top, our low interfacial tension oil, and on the bottom, high interfacial tension oil. And the right graph is over time, the contact angle, receding water contact angle for these two different substrates. And what we can see is that our MCT, so low interfacial tension substrate oil, spreads more than high interfacial tension oil, but dodecane spreads faster than MCT. And this was just for one substrate. So if we have a look at a few other substrates, we see a similar trend with MCT spreading more than dodecane. But dodecane spreading faster. So this all put together in what it will be the first part of my PhD is looking at this interfacial tension versus contact angle to try and characterize when a particle will transfer over an interface. So generally in this preliminary data, we can see that low interfacial tension gives a higher contact angle for all of the substrates. But I do need more data so we can fill in this nice little gap here. We're working on it. And then eventually in the future, looking into more of, or substituting our substrate with a particle instead and actually do a full particle phase transfer as well. Thank you.
Thanks, Amalie. That was a beautiful presentation. Why do you use mixtures of oils to get different interfacial tension instead of adding emulsifiers?
Well, first off, adding emulsifiers would create an emulsion when we start shaking, and we want to be able to separate the two phases from each other. And also, if we add an emulsifier, we might have difficulty with actually having particles transfer into the other phase as well. So, yeah. No emulsifiers. Everything as clean as possible in everything I do. To really just look at the particle phase transfer and nothing else involving in it.
Thank you, and that makes sense. Thank you.
Thank you, Amalie. Our last guest speaker for the day is Gavin Yeates. Gavin is an established mining industry leader with over 40 years of experience, including 35 years with BHP. He held senior executive roles leading group technology and as head of global technical functions including geoscience, mining, metallurgy and technology. Since leaving BHP, Gavin consults to mining companies, METS companies, governments and research organisations. Gavin has also contributed at board level for CRC OR, the AusIM and EMIRA. In addition to being chair of the governance board of PRIF, he is also the interim chair of the Copper for Tomorrow CRC bid. And Gavin continues to publish widely on innovations in mining and brings a deep understanding of the mining industry and its professionals, along with a vision for the future of mining. Welcome, Gavin Yeates.
Thanks, Ruth. It's been a pleasure to sit here today and sort of reflect back over, 6.5 years. The PRIF, as we saw this morning, has delivered. And it's delivered on a whole number of fronts. I won't go through them. But it's worth just reflecting on how the PRIF came about. It's an initiative that came out of the two mining companies in South Australia mining copper in complex ore bodies, BHP and Oz Minerals, renegotiating their Indenture Act with the state government to allow them to mine here. And the state government required of them to put some additional money aside for research in South Australia. Now, this is a really interesting initiative, similar to what we were discussing this morning. That went into a fund called the Premier's Research Industry Fund. And they called for bids from various research organisations on how that money would be spent, but it had to be spent in South Australia. And I think somewhat visionary, and to a little bit towards what Michael talked about this morning, the two universities got together and a single proposal was put forward to the state government, who ultimately accepted that proposal for a joint initiative between Adelaide University and UniSA. And I think that sort of was somewhat visionary, because look at where we are now, where we're talking about a single university. As part of that exercise, it involved going around and involving other partners. We've talked a lot about the mining equipment and technology services companies being part of that and necessary to create what is the PRIF today. We've heard all the outcomes, but I want to just sort of mention, yes, there's 4 going through to commercialisation, and I think we had a good discussion this morning about just how enormous that benefit is if you can partner up with the likes of Maptek and Magotteaux and people like that. But think about it from the perspective of, and maybe Simon can help us here, but once that algorithm for automatic domaining is into the software core system of Maptek, I presume at the next release it's available to a global audience of users, correct? So just think about that. It's scaling that commercialisation almost at zero cost, because it goes into an already distributed product with a global audience. So I think you can't overestimate the value of working with the Met sector. And there's 2 other projects that have really, I think, worthy of further support, and they are being supported. The one we've heard a little bit about, the MOF sensor, actually opens up a whole new world of sensors. And, you know, that could turn out to be actually one of the biggest findings in this entire consortium. For the PRIF to have been successful, it's an example of industry-led research. It requires an ecosystem, and that ecosystem, we've talked about having the mining people as the end users, and they've got to have and communicate clear objectives and the relevance of what we're doing. You've got to have the Met sector who can, yes, we call it commercialisation, but what they do is take an idea and turn it into a solution, a product that can then solve the problem for the end user. And you also have to have the researchers who have the hypothesis and the experiment and can take that idea through to a proof of concept. And that's got to be following methodology, and they've got to be able to adapt to the situation. But at the centre of that is collaboration. And I think that's been a key to the PRIF, is that level of collaboration. So one of the things I was asked to do was just to go through a couple of things that PRIF did really well, because we're getting towards the end, and I'm very fortunate to have been there during the whole journey. And PRIF's done some things really well, so we should reflect on those and in fact celebrate them. And I'd say initial industry engagement, defining those problems, breaking them down into what you've seen today as a research two programs, research projects within those programs, translation projects as well. That just doesn't happen. It's the result of some really good engagement, discussion, thinking through that problem. Then there's the research management. Obviously, the governance and reporting has been a key piece of that, and that was particularly important through COVID because we obviously couldn't meet, but the oversight of this has happened through some pretty difficult times. We've mentioned before the collaboration of the two universities. I have not seen a division with labels on shirts or anything like that. It's one team, and I think the fact that the universities are highly likely to merge going forward, I think is a testament that they're following what PRIF's shown can actually happen. But I'd also call out the culture that has been established within the PRIF community. It's been universally, from my observation, one of positivity and supportive, and really focus on both delivering results but having a good time and getting to know each other and being part of a team. And I think that's really important, not just for your research, but as you move out into industry, you've got to form parts of those teams too. And the quality of the research, there's no doubt, and we've heard it today, 4 projects heading through to commercialisation, 2 others really exploring a whole new area, the number of publications. We can't deny that this has been a successful initiative. So I think we really should celebrate these things. So congratulations to all involved. I think PRIF has really delivered on that money that came from the industry through the government, and the government put their trust in this consortium to deliver value for money. Some of the things that may have gone through that you might not have observed, but as I reflect, what helped the PRIF be successful? And there's some really important things I want to call out here. One is structure of the projects around the scientific method, and the last presentation by Amalie was a great example of how she was using the scientific method of hypothesis, experiment, observation, deduction to come to her research outcomes. So I think it shouldn't be, but it is a little bit unique that here today in Australia in 2023 we have to remind ourselves of the scientific method, but it underpins really good research. I've mentioned the single integrated team, and I think that and the way they've bounced off each other has been great. Another little tool that was introduced through the governance board asking questions has been the TRLs. Now, you've seen the reporting today against technology readiness levels. It's provided a really good tool to look at the progress of projects from idea through to commercialisation. And I would encourage you to continue to use that because it's very transparent in your reporting. You can see how you're progressing, and the toll gates or the success criteria to move from one stage to the next become really obvious and clear. The regular status reporting, and that's structured around both the board and its metrics, but also what the state government's required of us. And I think that's healthy and good. The annual report to the state governments required us to be very transparent and show both what we're doing well and where we're falling behind. And then there's the annual conference. And now that annual conference isn't just to tick a box, but it gives everyone the opportunity to share ideas, but also the development of the individuals, the researchers, to get up and present. And that's part of a key development. It's no good having a great research outcome if it can't be communicated. And we've seen some great presentations, but more than that, I've seen over the time the development of the people in their ability to communicate their research outcomes. And I think that's really important. And then we've talked a lot today about the translation and commercialisation, but having that embedded and bringing in external expertise when we needed it and not getting hung up on IP, and we heard that today too. There's always things you can do better, and that's, a self-learning organisation needs to look back. Some of those, just from my observations, it's always taken longer to recruit, particularly PhD candidates, than we think it does. And we heard again Peter somewhat frustrated by how long that is still taking. Fostering and maintaining end-user engagement. There are individuals that have supported all the way through, but just maintaining that end-user engagement has been difficult. It's been difficult to get access to data, access to sites, access to people. And we really do need to foster that collaboration between the industry and academia. I would say I've been around the industry for 40 years, and it's probably at its lowest level in my career. So I think we've got to do more, and it's not all the university's fault and it's not all the industry's fault. There's a lot going on both sides. There's a lot of pressures that need to be understood by both sides. But I think we've got to try harder to bring industry and academia together. This is one that comes up all the time. Yes, we did a good job in the end on translation and commercialisation, but the reflection is we should have started earlier. So the ability to take great research outcomes and bundle them up into things that can make solutions for the industry, that requires the researchers to get really involved with the METS companies and to engage with more strongly with the end users. And probably the other thing, and Nigel is probably tired of me banging on about the communication and knowledge of the PRIF on a wider audience. The PRIF's known reasonably well in South Australia, but it could, the sort of research that is being done here should be sung from the rafters nationally and internationally. Now, I know we do present at conferences and things like that, but I think we've got to foster wider networks and we've got to really publish our results to anyone who will listen. And it's a difficult one. When do you publish, or when do you start talking about what you're doing? Do you wait to the end till you've got everything wrapped up and a bow on it, or can you talk about progress throughout? So I would encourage people to be talking and publicising what they're doing much earlier than we do. So overall, the report card from me has been the PRIF has delivered and in spades. We've seen that with research through to commercialisation. We've seen it with the education outcomes for staff and students, and it's not just the academics. We've seen them ready to move into industry as well, and the PRIF's been able to develop that ecosystem of mining companies, METS companies, researchers, bringing in government where necessary to assist. And the Copper for Tomorrow CRC is leveraging much of the learning that we've got out of PRIF in that. And it has to be said that I think the state government's got really good value for money out of what's been delivered out of the PRIF. And that probably leads me to some votes of thanks. We go way back to its original inception. The concept was hawked around the industry by Steve Grano. And, you know, we've got to acknowledge that it was his baby at that time. Nigel's taken the reins and really has shepherded it through some pretty difficult times. Right in the middle of the PRIF was COVID, and it's pretty difficult to run a program like this that revolves around collaboration when you can't get together. So really thanks to Nigel and the effort he's put in shepherding this through. Obviously under the sponsorship of Michael Goodsight and the Institute. Tatiana I have to call out for her management skills and organisation, board minutes, all of those things are absolutely fantastic. Management reporting through to the state government. So thank you, Tatiana, for all your efforts. The staff and students of both universities. I think today we've seen the quality and quantity of your research. The state government and the department have been engaged throughout, and Ellen, thank you for your position and guidance on the governance board. The mining company reps, and you know, we've struggled at times to get enough engagement. I'll have to call out Kathy. She's been stalwart in that, always there. But without having end-user engagement, these things don't happen, and it's not easy. The pressures on mining company personnel today is enormous. We've talked a lot about the METS companies, but again, it wouldn't have happened. So thank you to all of those that were both, you know, come along to meetings, but provide data and access to equipment and all of the in-kind that we sort of wrap up and ignore is really appreciated. And all the other partners that have been part of this, and we heard from Mets Ignited and others, this thing doesn't happen on its own, and we don't deliver those results without a lot of help from people around. So thank you to all. It's been a great experience. We've still got a little bit of work to do to round it all out, so don't take your foot off the pedal yet, but it's been a pleasure to be part of it. So thank you very much.
Zara tells me that there are no online questions, so we'll move straight on to the panel discussion. Can the panel members please join us on the stage? Welcome to the stage Chris Greet, Manager of Minerals Processing Research at Magotteaux, Simon Ratcliffe, Head of Experimentation and Technology at Maptek, and PRIF researchers Richmond Asamoah, Difan Tang, Zhao, Hirad Assimi, and Dr. Yerniyaz Abildin. Professor Nigel Cook will be the facilitator.
Sorry? No, I'm going to stand. You sit. We've got 7 stools. It's a tight squeeze. And I'm sort of conscious we're running a little bit behind time, and I guess we're all very eager to go and have a drink together. But look forward to this last event of the day, this panel discussion. So, today we've heard from our researchers about their innovations, their inventions, and why they believe these solutions are so valuable for the minerals industry. I'd like to ask our 5 researchers here on the stage, first of all, to very briefly summarize what they believe were the biggest challenges they experienced during the research, and what are the greatest roadblocks for seeing those inventions or those innovations through to final commercial use. So I guess we'll take it here left to right. So we'll start with Difan, perhaps.
Thanks, Nigel. I think the biggest challenge was how to improve the accuracy of measurement while capping the total cost of implementing the sensor, because that is also the biggest roadblocks for the counterparts of our technology. Because if the implementation cost blow up, that could overweight the additional benefits obtained by implementing the sensor. Thanks.
Thank you.
Yes, for me, I'm just thinking it's like how to avoid not getting COVID is most challenging thing in the past 3 years. But for this project, I think I get well supported from the PRIF members and also from my industry partner and end-use partner. So I really hope I can just work hard to produce a better results. So that's everything I can like to say for today. Thanks.
Thanks, Nigel. I think one of major challenge, which is not perhaps unique, particularly where you have multiple organizations trying to address this kind of multidisciplinary challenge, is the different KPIs across, and so that makes progress in some activities potentially challenging. So I guess that through the COVID particularly has been challenging going to site, which is obvious, but we got massive support from Kathy's team and those on site, and so the available opportunities we were able to get on site and get work done. That, again, going forward in terms of commercializing such technologies is something that if you have committed people or very optimistic about the solution that is to be developed in the organization, that really helps to realize the outcome. So I think for our work, we've been very lucky enough to have people like Chris leading most of the Magotteaux side, and also Kathy and the teams from BHP directing who to talk to on site. So that's been very helpful.
So from PhD perspective, I have 2 things. It was really hard to set certain objectives before someone told me about TRLs. After that, everything became clear. Second one was Instagram. So I deleted that one, and now you see the success. Thank you.
So I guess I know now that why you're not answering my messages on Instagram. You have deleted it. So the challenge, I can say that I will continue on Shiz, that it was COVID for me, because it was the time that we were doing the data collection, and suddenly everything got baffled up. So I was supposed to sit there, talk with them, going through the man-in-the-loop discussions and the optimization. And for the commercialization, I also can say that the end users would like to see a tangible outcome for our works, for example, a user interface that they can work with the things that we develop in the backend. So if we can have those kind of things, if, for example, we had a software programmer in the pre-RAF to do that, that would have been fantastic, for example.
Well, thanks very much. Let's now ask Simon and Chris to comment on what they've seen and heard today and how they, as translation partners, view the pathways to commercialisation and perhaps most importantly, what should be done in the remaining months of the PRIF and how we can really ensure that the inventions do have a meaningful legacy and application. Want to go first, Simon? Or Chris?
Thanks, Nigel. I mean, one thing that's abundantly clear to me is that we do have a very special group here, and I think replicating this group is not going to be the easiest thing. One of the aspects of this group that I think is very special, and we've heard it with numerous questioning and presentations and discussion today, the group is highly aware of the things it can do better, but also very aware of the successes that it's had. And perhaps the element that I can bring to that discussion is, I suppose, harking back to my presentation a little bit, and that is just the long road to commercialisation and how taking a fantastic idea and some great research outcomes and getting it to the point where it's earning revenues off its own back to sustain its ongoing development and improvement and implementation. In my experience, not only with the PRIF, but in my entire career, it's a long, hard process, and I'm always trying to look for ways of accelerating that and trying to perhaps do more things in parallel rather than serially, so that we can get aspects of that started earlier with the METS companies or with the end users. It seems at the moment everything is very serial, and I've had a long career at Maptek now. I think it's well over 25 years, and you know, I've probably been involved with maybe 2 or 3 projects that are the now cash cows, and it's taken that long to get them into the industry and earning those sustaining revenues. And so I think in terms of the difficulties that are faced, that's how I'd sum it up. It's getting these ideas that have come out of the research and now getting them to the point where they can be, and I'll say that, globally sustaining, out in the industry in some way, shape or form, earning revenues that keeps them going year in, year out, and that builds Australian capability that's just going to continue to go up and up into the future.
Time is our enemy. But these things take time. The first Magotteaux pulp was built in 2008, and we're now 2023. What's that? Anybody good at maths that can tell me that's 15 years? And we've actually got units out there now that are collecting data. The algorithms are being developed, and they are actually being used to control parts of the process. But I guess from my perspective, it's not wise to stop just there. Yes, anybody can measure EH, pH, dissolved oxygen, oxygen demand and temperature. They're very, very simple things to measure, and they tell us a great deal. But there's more to it, and I think some of the other work that's been going on in the PRIF in terms of the MOF, in terms of the particle size thing, in terms of being able to measure frother concentrations, they're the next generation of sensors to put onto Magotteaux pulp that lead to more information, which means that the algorithms that we do develop are much better, much more robust, and give you better control of the flotation process in real time using real live data. So I think we've got a good start. There's a hell of a lot of very good information, and it's up to university METS companies and the mining companies to really pull together to try and bring these things into fruition. Is that a good place to start?
That's a great answer. Thank you, Chris. Just got a question specifically for Richmond now. What, in your view, is the greatest asset that the research environment and infrastructure in Adelaide has to offer the minerals industry?
Okay, that's a very good question. I'm thinking of three major things. So the first one is the ecosystem that the state government is creating around innovations and supporting research in South Australia. That is very positive. It helps development of new ideas. And that is a very good asset for other industries or organizations that would like to engage with the state, particularly enhancing their product. Another asset is with our mining company and also METS companies and engagement, a very high level of engagement. So particularly if you consider BHP very open, creating the platform for testing these various technologies and increasing the maturity levels, as we saw the increase in the CRLs for the various technologies, and the involvement that we're getting from our MET companies, Magotteaux, very supportive to help drive the research projects that are ongoing. I think the third one, which I'd like to talk about, is the world-class researchers and professors that we have, research leaders, and also having two universities that are very open to collaborate. And so two research leaders, major research environments, ready to work, bring on board their expertise to deliver world-class outcomes for the industry. This very unique environment, so for creation of new ideas and even development of existing technologies that we have. And I think these three will form a very great asset for engagement. Thank you.
Thanks, Richmond. How about one for Yerniyaz now? Now, you're a man of the world, and you're originally from another major mining country, Kazakhstan. Can you tell us perhaps what Australia could learn from Kazakhstan, and maybe what Kazakhstan might learn from Australia?
Yeah, it's really nice to be man of the world after getting degree. So, yeah, certainly, like a lot of things come to my mind. What Kazakhstan certainly learned from Australia, starting from machine learning in geoscience, in processing, autonomous trucks, and even like role model mines, how manage that, yeah, a lot of things. But when it comes to the what can Australia learn from Kazakhstan, I know that Kazakhstan in reserves, in uranium reserves are fourth, but in production first, if it didn't change recently. So might be like worth to see how they manage low-grade uranium deposits and so on. Yeah, that's all, I guess.
Okay, thank you. Maybe a question now for Chris. You know, how would you build upon collaboration between university researchers, METS companies, and industry end users? How can it be made still more effective than it is at the moment? What can we do to achieve that?
Jesus. Is that a loaded question?
It's a loaded question.
Well, I don't know. Money and time are, I guess, the big things, and crises. If there's a crisis, we act. If there's not a crisis, you know, it just goes along as per normal because we don't have to do anything because there's nothing to worry about. I think the requirement for copper and other critical minerals to electrify ourselves and move away from fossil fuels is the beginning of the crisis. I think that will then drive the mining companies to become more efficient. And for them to become more efficient, they will need the METS companies to supply them with quality products and services and use our knowledge from multiple sites to help them. And that also means that we need to draw in the bright young minds from universities to help come up with the new sensors, the new technologies we need to become more competitive and have better resource utilisation, so that the tailings dams that Max works on in the future will be mined for silica and not copper.
That's really interesting, isn't it? And I guess sort of linked on from that, maybe this one's for Simon, the major problem I think we've identified is the real lack of skilled personnel with the specific and broad skill sets needed to meet the ever-expanding challenges of mining more and more low-grade ore cleanly and with reduced footprints. How can the METS industry adapt and always remain one step ahead of that?
Yeah, how do we get students back into the relevant courses? That's a real burning question, I think. My bosses are telling me that the future of mining is going to be peopleless with huge degrees of automation, and we need to be planning our software processes and systems and our licensing strategies, et cetera, around having much lower head counts. But I really don't think that's not really going to solve the problems. We need thinking people to solve problems, and we need the next generation of people coming through like these people here, but more and more students willing to do the technical subjects, get into metallurgy, mineral processing, get into geosciences, get into just maths and physics and chemistry. And it seems to me that the trend is not going in the right direction there, and I'm not quite sure of the solution, except to keep reaching out and sort of putting it out there that the merits of the mining sector and the mining industry in terms of the future of the planet are very important and very strong, and we've got to get that message probably back into primary schools.
I agree. Thanks, Simon. Maybe this one's for Difan. If you could start your project all over again, what would you do differently?
And Nigel, I think you're asking me the hardest question. This is the best solution we have found and developed so far, I believe. It has so many potentials. So I think I would do the same thing if I start over again.
Okay, that's fine. Okay. Sort of variant of that kind of question, I'm going to ask our dynamic duo here, she and Hirad. If you had another 5 years of research funding for your work to do whatever you wanted, where would you see that work going in 5 years' time, and what could be potentially the products that might be developed with another 5 years' worth of funding?
Yes, thanks. For the short-term objective, I would say I can finish a demonstration system, how we integrate two research projects and optimize the reclaiming process. So we have a small-scale demonstration which are working together with another university colleague. We're trying to demonstrate our results, and also for the full-sized stockpile, we're working closely with our translation partners, ECHA, to use their system, building 3D stockpile models, and also to optimize the results. And if I can get further fundings after the PRIF, I would say the questions Simon and Gavin asked in the morning, would be good options for me as well. So trying to thinking about the collapse of the material, how can we modeling that? And also, how can we do a dynamic scenario integration of the stacking and reclaiming together, trying to optimize both. Thanks.
Okay, thank you. Hirad?
So thanks for your generous question. When we can sign the...
No, we're not giving you the 5 years. Right?
So,
you'll have to take that up with the state government.
As the application, she mentioned the things that we can do, but I would look at it from the methodology perspective. There are different avenues to pursue to improve the things that we have developed from the artificial intelligence perspective and other computer science tools that are available there in the state of the art. So having that and also integrating with the applications that she mentioned and adding those dynamic operations, yes, I see that may lead there.
Okay, thank you. Okay, I think that's probably enough dumb questions from me. So let's see if there are any questions in the audience for our panel members. Who wants to start? Gavin.
So a little bit follow on, not so much funding. What's the constraint to the speed of the research? And if we wanted to speed it up twofold, what would we need to do? And maybe the researchers can answer that.
Yeah, I have a very brilliant answer to this question actually, is the availability of the data. So it means that whenever you get your data, you are ready to play around. So it means that if you have a room to play around, as soon as possible you finish your research. Otherwise it's really hard. And some of the colleagues, they face some problems, delays, and mentally sometimes it's also breaking some things. So otherwise data availability, I think, is key, one of the keys, definitely.
Okay, I just have to go. So I'm seeing that in a couple of ways because it depends on which aspect. All right, so if we're looking at the postdoctoral activities, we've got constraints of like data that Yerniyaz mentioned. I remember we had a meeting with Kati and Bill and a couple of years back and tried to develop a way to help get data set, which really was helpful, where we can able to get data straight from PHP to work on. Perhaps a similar model on the operation side where someone is easily integrated into the operation to help facilitate activities. So I did mention the KPIs potentially around operations. So on the operation point of view, the managers will be looking at their own KPIs, and so having someone to, which we have a contact in there, but that potentially delays getting things done. So perhaps a similar thing on that front can help. That is activities on the translation of postdoctoral related activities, getting them done quickly. And I'm trying to imagine the PhD side of things. Definitely there's been some aspect of data access, which also affected getting to site, affected them. But maybe I'll leave it there, but PhD will be a different look at, particularly giving students the opportunity to come up to speed and then ramping up on targets or outcomes. So that may be looked at in a number of ways as well. Yeah, I'll pass it on from there.
Yeah, sure. So I suppose that PhD students are the engines of the research in the universities, but they also come to go through a journey for themselves. So they try to learn how to do the communication, especially if they are international, they start to learn how to communicate, how to do the time management, research management, all the things. So I suppose that if there is a bigger, maybe supervisory panel or maybe more defined research project that what they would like to do as he mentioned that we would like to have data available. So also what is the next steps that otherwise the PhD student would like to find their own questions, right? So that would damage the speed up, in my opinion.
Yeah. If I add to the postdoctoral aspect, that definitely means more resources to support people to do multiple things across different project activities. And then that means that you are pushing PhD students to quickly ramp up, come up to speed. So some of those can be worked into details as well.
What I can thinking about is more like the advancement in the technology. So basically, we see the new technology coming every day, and the learning process of grabbing those technology and apply those technology to answer a real engineering question, it's really take a long time. So the learning process, it is, if we can speed that one up, I think will be much more helpful as well.
For new sensor development, I think the calibration is the most critical and time-consuming part. So to accelerate the development, a possible solution would be to directly engage with industry and perform site testing, site calibration at the same time.
Maybe I'll add to it that if we consider the disruptions that we experience, I'm speaking in terms of our projects that we've looked at, work with Magotteaux, the disruptions that we experienced, the outcomes that we've been able to get, you clearly see the commitment and the support that we got from Chris. Maybe I call Chris a lot too much. Maybe perhaps he may blacklist me soon. But he's been very supportive on that front as well. So that has helped move things quite a lot. So those supports also drive things a lot.
Well, I think you put your finger on it. A lot of it is personal relationships, developing those personal relationships. I remember, Chris, you saying, you had to have, a researcher had to have somebody in the company who was their defender and would defend the project. Without that, it's not doomed to fail, but may far more likely fail. You've got to have that defender in the companies. I remember you saying that when we first started talking about this. I think we've just got time for one more question from the audience, and then we're going to wrap up and have a drink. Having said that, probably nobody's going to put their hand up now. Well, if that's the case, I think we're going to thank the panel here. Thanks for being here. There's just a couple of small formalities before we can break, and I'm going to ask Simon to please stay up on stage for a moment. But I'll let you guys down. All right. So first of all, there's a couple of people we do need to thank, without which today would not have been a success. And I guess first of all, I'd like to thank Tatiana for all the fantastic organisation involved in this event. You've done everything exhaustively, confidently, repeatedly, sometimes sending out invitations and letting everybody know what's going on. We owe a lot to you for just keeping this whole consortium running smoothly, producing, and all of the rest of us organised and knowing what we're supposed to do down to the smallest detail. Without you, it would not have been possible. So a big round of applause, please, for Tatiana. And secondly, I think we need to thank Ruth for her fantastic job again as Master of Ceremonies today. I think this is the third annual meeting that you've done for the PRIF, and we just don't know what you're going to be doing in October next year because you do a great job. Thanks very much for keeping everybody on time. All right?
And Tatiana would also like to thank Nigel for facilitating the panel sessions. There were excellent discussions and your fabulous leadership in PRIF. Thank you, Nigel.
So we thought it appropriate just to close the meeting to have a sort of a final word from one of our key translation partners, and I've asked Simon to just say a few words.
Thanks, Nigel. Honestly, I think everything's been said, and I don't wish to hold people up from their drinks. But it really is great to see Nigel and Tatiana, two such strong, capable people, keeping this show on the road over the last several years and doing it in a very congenial way that I think you can see has built the teamwork that we see here. And Bill and Peter, head of the respective programs, you know, everyone naturally forms those relationships and linkages that I think we can see the spirit in the room today that's made it all hang together extremely well and work really well. On a personal note, I would just like to thank a lot of people in this room actually just for teaching me things, just for letting me learn new things. I mean, my background is in computer science and computer systems engineering. I can design logic gates on chips and things like that. I've picked up a little bit of geology through a bit of osmosis working at Maptek. But with the PRIF, my eyes have been open to a whole other world, particularly a lot of the work that's occurring at UniSA in sensors and mineralogy and minerals processing. This has been a fantastic experience for me, and I hope to stay engaged in these new horizons and new fields for me. So without any further comments, let's wrap it up there and let's go and have some drinks.